Example 4. Given f of x equals e to the x over x, find the tangent line at x equals 2 and use this for linear approximation. So again, we have our point of tangency, x equals 2. We need to make sure we find out the y coordinate here. So y is equal to, plugging into 2 into that equation, I get e squared over 2 as a y coordinate. I'm going to differentiate this so that I can calculate the slope. So f prime, this is a quotient, so we're going to need to use quotient rule. So we get e to the x times x minus e to the x times the derivative of the denominator, which is 1, and then the denominator squared. So I'm going to simplify this to e to the x minus 1, and this is over x squared. Okay, so using this derivative, I'm going to calculate the slope at x equals 2. So here I'm going to end up with e squared over 4 as the slope. So the linear approximation equation for this is going to be y equals, the slope is e squared over 4, and the coordinate is going to be at x equals 2, y equals e squared over 2. Okay, so there's my linear equation. Now this line can be used to approximate the value at f of 2.1. So f of 2.1 is going to be approximated by the y value on the linear equation at 2.1. And when I plug this in to my calculator, I'm going to end up with e squared over 4, 2.1 minus 2, plus e squared over 2. Okay, so plugging this into the calculator, we end up with a value of 3.879. Okay, so that's our linear approximation. So we don't have a picture of this, so we're being asked to determine the approximation is if it's over or under estimate by checking the concavity. And again, if we go back to our criteria, concave up means underestimate, concave down means overestimate. So I'm going to work out the concavity here by working out the second derivative. Okay, so the second derivative is going to be a little bit messy looking. So I'm going to need to use product rule in the numerator. So I end up with e to the x minus 1 plus e to the x times 1, which is derivative of x minus 1, and then multiply that by the denominator, x squared. Okay, so that's the product rule and the first part of the quotient rule. And then I get e to the x minus 1, and then differentiating the denominator, I get 2x. Okay, so that's all over the denominator squared, so I get x to the power 4. Okay, so this is something I should simplify. I'm going to, first of all, expand out those brackets, so I get x e to the x minus e to the x plus e to the x. Okay, those are going to cancel out. So I'm just going to cancel them out right now. And then times x squared minus, if I expand this all out, I should put this in brackets as well, just so that I don't lose track of this. It's going to be x times 2x, or 2x squared e to the x, minus 2x e to the x. It's all over x4. So I end up with x cubed e to the x minus 2x squared e to the x plus 2x e to the x. I have a common factor of x and e to the x. Okay, so I'm going to cancel out one of those x's. So in the denominator, I'm going to end up with x cubed. I'm going to factor out the e to the x, and I'm left with x squared. Make sure that's clear. X squared minus 2x plus 2, and there's my second derivative. And all I want to do is then check to see that the concavity near 2 is going to be positive or negative, so I'm going to check my concavity. So the second derivative at x equals 2, when I plug it in, well, I know that e to the x is positive, the denominator is positive. So we get, if I look in the brackets, I get 4 minus 4 plus 2. Well, that's all positive. So I know that I have positive concavity. Therefore, our linear approximation is an underestimate because it's going to be below that concave up line. So that's underestimate. Okay, so that is that. Okay, so our estimate was 3.879. Now, the actual value when you type it into the calculator is 3.889. So again, we can confirm that is an underestimate. And we can work out the error by taking the difference. Okay, so we have 3.889 minus the approximate value of 3.879. Okay, and that represents the difference, which is equal to 0.01. And if we want to work out the percentage difference, we can say that the percentage difference is equal to the difference 0.01 divided by 3.889, and that's approximately about 2.2%. Okay, so 0.2% error.